Hi friends, myself Dr. Darshan Jani, and today we learn about important topic of chemistry, that is photochemical reaction. Also, don't miss to like and share the video, subscribe the channel Chemistry Online by Dr. Darshan Jani, and hit the bell icon to get regular notification for such important videos. So friends, before we discuss about photochemical reaction, we should know about certain basic principles and terminologies of photochemistry. So we will start from basic principles of photochemistry. So there are two ways by which we can provide the energy to the molecule. So as we can see on the board that there are two ways by which we can provide the energy to the molecule. The first one is by raise or increasing the temperature of molecule, which is called thermochemistry, and the second one is by applying irradiation to the molecule, which is called photochemistry. So actually what will happen, the translational kinetic energy of the molecule can be raised by providing photons in form of energy by EMR, that is electromagnetic radiation. So what will happen, it will cause the electronic excitation of molecule, and due to this electronic excitation, what will happen, electron will transist from, as we earlier know in 12th science or FYSYTY BSc chemistry, that is highest occupied molecular orbital HOMO to lowest unoccupied molecular orbital, that is LUMO, right? And or electron transits from bonding molecular orbital, that is BMO, to ABMO, that is anti-bonding molecular orbital. And according to electronic transition or essential condition for electronic transition, if we discuss the same thing, then it can be explained as singlet to singlet as well as triplet to triplet transition of electron or photon is known as allowed transition, while singlet to triplet or triplet to singlet transition of electron or photon is known as forbidden transition. So these are the basic principles or way by which we can define the term photochemistry. Right now we discuss about different types of electronic transition takes place in organic molecule. So as we can see on the board that according to energy level or increase in energy, we can define the orbital as sigma bonding, pi bonding, non-bonding molecular orbital, pi anti-bonding, and sigma anti-bonding molecular orbital. So what will happen, there are four possible transition, either from non-bonding molecular orbital to anti-bonding molecular orbital, that is n to pi star, then non-bonding molecular orbital to anti-bonding molecular orbital, that is n to sigma star. Again the third one is bonding molecular pi bonding molecular orbital to anti-bonding pi star molecular orbital, which is denoted by pi to pi star transition. And last but not least, that is sigma bonding molecular orbital to sigma anti-bonding molecular orbital, which is defined or denoted by sigma star, which is denoted as sigma to sigma star transition of electron in organic molecule. So these four, that is n to pi star, n to sigma star, pi to pi star, and sigma to sigma star, all these four are possible electronic transitions in organic molecule, right? So these are the basic principle or transition which is carried out in organic molecule when we apply energy in form of photon, right, either by raising the temperature or by applying photo irradiation. So friends, after discussion of basic principle of photochemistry, we should know about certain basic terminology of photochemistry before we start photochemical reaction, and most of such terminologies are included in Jablonski diagram. So before photochemical reaction we will discuss about Jablonski diagram. So when we discuss about Jablonski diagram, so what will happen, most organic molecule will remain in spin paired state, in ground state, which is denoted by S0, as we can see here. Then what will happen, when we apply energy in form of photon to the molecule, so these molecules are excited to higher energy level, right, with conservation of spin, and this excitation is known as photoexcitation when such molecules are shifted from S0 to Sn state. Now what will happen, friends, electrons are quickly cascaded from higher energy level to lower energy level due to very small lifetime of such electron in higher energy state, and due to which such process of cascade of electron from higher energy state to lower energy state is known as vibrational cascade or vibrational relaxation, which is denoted by Vc or Vr, as we can see in the chart that when molecule is remain in ground state, which is denoted by S0, then what will happen, such molecule having electron in spin paired state, as we discussed. Then what will happen, when we apply energy in form of photon, so such electrons are excited to higher energy level, which is called photoexcitation with conservation of spin. Then what will happen, such electrons are quickly cascaded from higher energy level to lower energy level due to shorter lifetime, and due to which what will happen, when such electrons are shifted or cascaded from higher energy level to or higher energy state to lower energy state is known as vibrational relaxation or vibrational cascade. So it is important for us to know. Now next important term, or before we start next important term, we should also know about that this vibrational cascade or vibrational relaxation is a energy dissipation process, right, and the excess of energy is liberated in form of heat, which is non-radiative part, right, and also such vibrational cascade from one state to other state is known as internal conversion, which is denoted by IC, as we can see on the board that when vibrational relaxation, as we discuss, from one state to another state is carried out, then such process is known as internal conversion, as we can see on the board, right. Then what will happen, again this internal conversion is a one kind of energy dissipation process and can't lead to chemical transformation, as we have discussed earlier that here the electrons are for very small period of time, having small lifetime, so it will not undergo chemical transformation, right. Next important term, that is electronic energy transfer. So we discussed, friend, that is what is electronic energy transfer. So when excited molecule is in ground state, it will transfer its excess of energy to the acceptor molecule. Then this excited acceptor molecule will transfer such energy and return to the ground state. Then such process is known as electronic energy transfer, and which is denoted by ET. As we can also see here in diagram that what will happen, this vibrational cascade or vibrational relaxation, then internal conversion, right, and the most important term, that is electronic energy transfer. Now last we discuss about certain more terminologies which are used in photochemical reaction or photochemistry mainly. So first one is fluorescence. So what is fluorescence? So as we can see here that fluorescence is a one kind of radioactive unimolecular energy dissipation process, right? So as we can see on the board that what will happen, S1V0 state, right, when the molecule is transferred or shifted from S1V0 to S0, that is first excited state to ground state, then what will happen, the excess of energy is liberated in form of radiation, that is radioactive unimolecular energy dissipation, and such process is known as fluorescence, as we can see in the chart. Also this is a lower frequency than absorbed radiation, and also as we have discussed that S1Vn to S1V0, as we can see here that S1Vn to S1V0, right, again it is a loss of energy in form of heat, which is a non-radiative path, and it is known as vibrational relaxation or vibrational cascade, as we can see here in theory as well as in chart also. So this is about three important terms, that is vibrational cascade or vibrational relaxation, internal conversion, electronic energy transfer, and fluorescence. Friends, remaining two important terminologies are intersystem crossing and phosphorence. So let we discuss about two terminologies. So first one is intersystem crossing, ISC. So it can be defined as, there are two conditions for or we can also say that two essential conditions for intersystem crossing, and which are those two conditions. So first one is, if S1 state is long lived and corresponding triplet T1 state is close enough, then what will happen, as we can see here that transition of electron from S1V0 to T1Vn or S1V0 to T1V0. Again this transition is a slow transition because it is a spin forbidden transition, right? It is not a spin allowed, as we have discussed earlier that singlet to triplet and triplet to singlet transitions are forbidden. So again this is a slow process and it is due to the spin forbiddenness. So this non-radiative unimolecular energy dissipation from S1V0 state is known as intersystem crossing, as we can also see from the chart that transition of electron from either S1V0 to T1 or S1V0 to T1V0, right, is known as intersystem crossing. And next and last important terminology, that is phosphorence. So when we discuss about phosphorence, So what will happen, as we know that when the photo excited molecule in T1V0 state, so again it will undergo photochemical changes and it will lose excess of energy through a unimolecular radiative pathway from T1V0 to S0. Again it is a slow process because same thing, that is pin forbiddenness, right? So this process, that is transition of electron from T1V0 to S0, is known as phosphorescence. So friends, these are the important terminologies. In short, we can see here that VC, vibrational cascade, VR, vibrational relaxation, ISC, that is intersystem crossing, H mu F, that is fluorescence, and H mu P, that is phosphorescence. So these are the important terminologies for photochemistry. Now in next video session we will discuss about photochemical reaction, right? Also don't miss to like and share the video, subscribe the channel Chemistry Online by Dr. Darshan Jani, and hit the bell icon to get regular notification for such important videos. Thank you very much.